Hi, this is Ms. McGovern, and in the sixth video in the electric circuit series I'm going to introduce to you the concept of resistance. So I've got a circuit here, it has two bulbs. The total is 12 volts, but one bulb has 9 volts measured over it and the other bulb has 3 volts measured over it. What makes these bulbs different that they'd measure a different voltage over each? So the idea is it's resistance. Each bulb, the property that makes it different is electrical resistance, and it's how much each bulb or each component opposes the electric current trying to get through it, or resists that electric current. So it has kind of some similarity to friction, where friction can oppose motion. More friction means that more motion is slowed down. In this case, more resistance means more current is slowed down. So resistance is measured in ohms as the unit, and the symbol for ohms is the Greek letter omega. So we need to know rules for how you find the total resistance in series and parallel. So to start with, in series, it's really easy. You just add the resistances together. So here I have two bulbs with different resistances. The total resistance in the whole circuit, i.e. not just how much each bulb resists current, but how much the whole circuit resists current flowing through it, is just 1 plus 2, which is 20 plus 30, which gives me 50 ohms. I can do the same for parallel. So here I have a parallel circuit. One I have 6 ohms and the other I have 3 ohms. The formula for that is a bit more difficult. Okay, it's a 1 over the total is equal to 1 over R1 or RA plus 1 over RB. So in this case, my RA, my first resistance is 6 ohms, my second is 3, so I just plug that in the formula. If I wanted to add two fractions with different denominators, what I've got to do is make them the same. So I made the 1/3, I multiplied that whole fraction by 2 over 2, and that gave me 2 over 6, which is the same as the 1/6. I can add those together, give me 3/6. A lot of people stop there, okay, but this can be simplified. 3/6 is just a half. You've got to do the last step, and you're not trying to find 1 over the total resistance, which is what I've got written there. You're trying to find the total resistance. And so the shortcut is you just flip the whole thing. So you flipped 1 over 2 becomes 2 over 1, which is 2. Another thing to remember is in parallel circuits, the total resistance is always smaller than the individual components. So we had 6 ohms, we had 3 ohms, but the total turned out to 2. How is that possible? How can I have less than the total? Less than the individuals? Well, remember, resistance is the ability to resist electrons flowing through. If we have this resisting some electrons, but then we put another one in, resistant electrons have got a choice to go through one path or another path. Because you're opening up more paths, you're decreasing the total resistance. It's easier for the electrons to finally get through the circuit. And that's why the total is always less than the individual components. So a bit of a difficult one. I've got 3 things in here. I like to think I'm working from the inside out. So I'm going to do the parallel section first. So you just do it a section at a time. So I've got RA and AB, 1 over 6 plus 1 over 6, that becomes 2 over 6, which becomes simplified 1 over 3. Flip it. Total is 3. That's just for this section here. Now I've got to add on this RC as well, and that's in series with it. So RC plus 3, which is 3 plus 3, equals 6 total.